Okay, so today and tomorrow. This is for today and tomorrow. We're talking about extrema. Extrema. Extrema can be a couple different things. What we're going to focus on are maximum minimums. All right. So maximum minimums. Maximums mean top, right? Top. Minimums mean the bottom, right? But there's different types of maximum minimums. Okay. So you can see from the picture here, absolute. Absolute maximum minimums. It means from A to E, right? This interval goes from A to E. From A to E, right? From A to E, D is the absolute maximum. Why is that the absolute maximum? Why is at D the absolute maximum? Mm-hmm. Mm-hmm. It's the highest point or the highest peak, right? It's the absolute top, right? And then A is the absolute minimum for the opposite reason. It's the absolute bottom, right? It's the valley. It's the lowest part, right? But here's the thing. Within those, we have relative maximums and relative minimums. Sometimes they're called local, but for the most part, we call them relative. Okay, relative maximum minimums mean peaks and valleys still. There's still peaks and valleys, right? They're just not as tall as the absolutes or low as the absolutes, right? Like this guy here, B. B is a maximum. It's just not the absolute maximum, right? But in this area here, it's the tallest, right? So any peak, any place where the function rises and then falls after is called a relative maximum. Okay. Now it could also be a absolute maximum, but it's definitely an absolute. It's definitely a relative. Okay. Same thing with the minimums. This guy here, C is not the lowest point. A is. But for this area, and it definitely changes from decreasing to increasing, right? If it changes from decreasing to increasing, that's the definition of a maximum or minimum. So the definition of a minimum is the function changes from decreasing to increasing. That creates the minimum. The definition of a maximum is the function changes from increasing to decreasing. So if we see that change, it's a maximum or a minimum. Okay. So what do you notice about all of the maximum and minimums in terms of derivatives? In terms of derivatives, what do you notice about all of the maximum and minimums? We've kind of talked about this before, but since we're going to be dealing with it today, I wanted to bring it up in terms of derivatives. So when you're thinking about derivatives, what do you notice about the maximums and the minimums? Think about derivatives. What a derivative is. What do you notice about all of those points? What's true about at B, at C, at D? What's true at A? Mm-hmm. You're yeah. Okay. So the yeah, this one's a little more at a point, right? It's not necessarily. It's got a curve, slight curve. This one's got a little bit more of a curve. This one's got a little bit more of a curve. What do they all have in common, though? What do they all have in common? That's good. That definitely is something to notice. But what do they definitely have in common with derivatives in terms of derivatives? So if you're finding derivatives at all of these points here, what would it be? Yep, you read. Not undefined. Close. You're close. They all have a. Because remember, undefined means the slope of the tangent line's vertical, right? So they don't have a vertical tangent line. What kind of tangent line do they have? Horizontal. Yeah, they actually have a horizontal. Everywhere a maximum minimum occurs has a slope of 0. That's one of the ways we're going to find them. One of the ways you can find a maximum or minimum is if they have a slope of 0. Okay, it's called a critical point, which we're going to talk about on the next slide. But that's how we locate. There's two ways that we locate maximum and minimums. First of all, they have to have a slope of 0. They have to have a derivative of 0, right? And once we do that, we can tell, okay, does the slope change from increasing to decreasing? Or sorry, does the function go from increasing to decreasing? If it does, it's a maximum. Or does it go from decreasing to increasing? If that does, it's a minimum. Okay, that's the two ways we can tell. So we're gonna be able to tell. We're gonna look at functions, not pictures, and see where is it increasing, where is it decreasing, where is the maximums, where are the minimums. Is it a relative maximum? Is it a relative minimum? Is it an absolute max or min? That's what the purpose of all of this is. We're gonna be able to tell all those things because you can look. There's no graphs after this page. There are no graphs, right? And this is non-calculator work. So we have to be able to do that using derivatives. Okay, and that's what the lesson is. Okay, so important stuff to know. A function may have both a maximum and minimum over an interval. Only a maximum, only a minimum, or neither a maximum minimum value over an interval. Okay, so it can have both, it can have one, it can have the other, or it can have neither. Okay, how would it have neither? How would a function, so picture a function, let's see, let me get a, how would a function, can anyone tell me a function that would have from A to B, so it goes from A to B, that would have neither a maximum or a minimum? Yeah, just that guy right there, right? That doesn't have a maximum or minimum because every point is a maximum or minimum. So if every point's a maximum or minimum, it doesn't have one. Okay. So yeah, that's what that says. As long over an interval. So the yellow part, it's not yellow on your paper, but it's boxed in because it's important. Critical values or critical points. Sometimes we'll call them critical points. Critical values or critical points are points or values of x where the derivative is 0. Horizontal tangent lines. Or there is no derivative, aka vertical tangent lines, right? So that's where we're going to deal with today. Every single one of these today, we're going to find a critical value because that's going to tell us where the derivative is 0, right? So we're going to tell us all of those. That's where the derivative is 0, or it doesn't exist. So if we have, because you can have, not on this picture, but I can have something that looks like, I can have a graph that looks like this, right? This right here is a minimum, right? That's a minimum, but it doesn't have a derivative. So I would look for the point where the derivative doesn't exist. Okay. So that's where the other one is brought into, because just because it doesn't have a curve bottom or top doesn't mean it's not a maximum or minimum. Okay. Okay, so the critical points. The critical points are x values. Okay, so when we find a critical point or a critical value, it's an x value. It's not a y value. Okay, while maximum and minimums are y values. So if they want us to actually find the maximum or minimum, we got to find the y values. That's what we're going to do today. In other words, if the point 270 is a relative minimum, so if we find that the point 2 comma 70 on some function is a relative minimum, we would say the minimum is 70 and it occurs at 2. Okay, because sometimes they'll ask you what's the minimum. They don't want the point, they just want the y value. Okay, or what's the critical point? That's just the x value. Okay, so each one serves a purpose, but sometimes they want one over the other. Okay. Okay, so one of the ways we're going to find these maximum and minimums is the first derivative test. the first derivative test. Okay? This is what the first derivative test says. It's pretty, if you read it, it kind of makes sense. It's just kind of logical. If a derivative, so I'm right here. So if a derivative is zero, or sorry, greater than zero. So what type of numbers are greater than zero? What type of numbers are all going to be greater than zero? Positive. So if the derivative is positive, that means the function has to be increasing. Does that make sense? If a derivative is positive, does the function have to be increasing? Yeah, the slope is positive, right? If the slope is positive, that means it has to be going up. It can't be going down, right? If the derivative is negative, it has to be decreasing. If a derivative is negative, it has to be decreasing. So if it has a negative slope, there's only one way for it to go, downhill. Now there's various forms, right? There's like that and there's like that, but it has to be going downhill. And if a function equals zero, it's a critical value, okay? It's a critical point or critical value. That means right there is a max or min. At that point is a max and min. That's what we're looking for. Okay, so that's what the first derivative test is. Find the derivative. Is it positive or is it negative? If it's positive, it's going to be increasing. If it's negative, it's going to be decreasing. If it's equal to zero, that means it's a peak or a valley. It's a maximum or minimum. Okay, so we're going to do the first one. We're going to do the first one together. We got to find all of that stuff here. So for each guy, we got to find the critical numbers or the critical values. We got to find where is it increasing or decreasing. And then all relative extrema. All relative extrema mean maximins. Where are the relative maximum minimums? Max and mins. There might be multiple. Okay. First thing we always do is find the critical numbers. To do that, you got to find derivative. Okay. So the first thing we're going to do is we're going to find the derivative. Always find the derivative first. Okay, then what did we say about where the critical numbers are? It's a critical number because what's true about the derivative? It equals zero. So we got to set the zero. We're going to replace that with a zero. And I got to solve for x. Okay, go back to math 2, math 3. How do I solve for x here? How do I solve for x? There's a couple different ways. There's an easier way and there's a harder way. Which way? I'm not going to tell you which ways, but what are we going to do? GCF. There's a GCF. Anytime there's a GCF, use it. So what is the GCF for this guy? What can I divide both of them by? 3, definitely 3. What else can I divide them by? They also could take away a power of x, right? So that's going to go in the front. Always GCF in the front. Divide, and I get x minus positive 4. Okay. Reverse distributive property. That's all I really did. Reverse distributive property. Okay, how does that help me solve for x? What am I going to do now? Some of you guys are doing it because you already know this. Tell me, help me out. What do I do? How do I solve for x? How does that help me solve for x? What do I do next? There you go. Set them equal to 0. Zero product property. If this guy times this guy equals 0, one of them has to be 0, or both of them. So zero product property says assume both. divide by 3. Add 4. There are my critical values. So these are your critical values or critical points or critical numbers. However you want to call them, they're all the same. Those are my critical values. So at 0 and at 4, there has to be a maximum or minimum. Okay? Because that's where the derivative is 0. Well, my next step is, are they maximums or are they minimums? Okay, so I got to figure out, I got to determine, are they maximum points or are they minimum points? Okay, in order to do that, this is where I'm going to use the first derivative test. Okay, so the first derivative test, let me get some, is a line. We use a number line. On the number line, the critical values are going to go. So 0, so in this case, we're going to put a 0 and I'm going to put a 4. Okay. You don't have to have all the other numbers, just the critical values. So what I'm using this number line for is I want to determine before 0, is the function increasing or decreasing? Between 0 and 4, is the function increasing or decreasing? After 4, is the function increasing or decreasing? Right? Because I know at 0 and at 4, they change, right? So I want to know, does it go up and then change to down? Does it increase and then change to decreasing at 0? Or does it go decreasing and change to increasing? This is where I use the first derivative test. So what did the first derivative test say? Go back to the first page. The first one right above it, or to the left. So you look to your left, bottom left corner. What does the first derivative test say? If what is what? It's increasing. What does it say? It's increasing, right? If the derivative is positive. And then the next one says what? If the derivative is negative, it's decreasing, right? And the last one we're not concerned about because we already found those points. The last one where it's 0, we just found where it's 0. So we're not worried about it being 0. We're just worried about it positive or negative. So how do I determine whether it's positive or negative? What am I going to do? So if I want to know for these guys over here, by these guys over here, I mean any number that's less than 0. Any number that's less than 0. -1, -1,000, -1,000,000, right? For these values, any number between 0 and 4. 1, 2, 3.8, 2.64, all of those numbers, right? And then any number greater than 4, 5, 7, 1,000,000, whatever, all these numbers, right? Now, which numbers do you use? It doesn't matter which numbers you use because it's all going to be doing the same thing. It's all going to be increasing or decreasing. So you don't have to worry about using multiple numbers. Just pick a number. Pick a number that's easiest to use that falls into this area here. Okay, same thing here. Same thing here. Okay. I would pick the easiest numbers. The numbers preferably you can probably do in your head. That's what I would choose. I wouldn't choose numbers that are crazy big or crazy small or crazy difficult to use, decimals, fractions. I wouldn't use those. 0 is a good number to use. We can't use 0 here. Why can't I use 0 here? Why is 0 not, I don't want to use on this problem here? Yeah, we've already identified it as a critical value. It means if I plug in 0, it's not going to be increasing or decreasing. It's going to be 0. Same thing with 4. I can't use 4. I can't plug in 4 because I'm going to get 0 if I plug in 4. Okay, so let me pick a number here. I'm going to pick -1. -1 is definitely less than 0, but it's not crazy big, and we'll see what happens. So where am I? The question is, where am I going to plug it in? You have two options: the original or the derivative. And if you're not sure, you have two ways to check. Look at your notes. It's to the left, bottom left. And what's the test called? What kind of test is it called? First derivative test, right? So if it's a derivative test, I'm going to use the derivative. That's why it's called a derivative test. This is the only time you plug in anything to the derivative. Usually we plug it back into the original. So I'm going to plug it back into the derivative. So the derivative is 3x squared minus 12x. So I'm going to plug in f prime of -1. See how I label what I'm doing here? A lot of you would just do this. A lot of you on tests would do this. 3 -1 squared minus 12 -1. If someone knows calculus, they can kind of guess what you're doing, but you don't want people guessing because they could guess wrong, right? When you're grading your paper, the last thing in the world you want them to be doing is guessing. But if you do this, that explains exactly what you're doing. You're taking the derivative and you're plugging in -1. It's important. Those things are important because the last thing in the world you want people doing when they're grading your tests or quizzes or AP tests is guessing what you did. Okay? I think they plugged in -1 there. Okay? Okay, so plug it in, I get 3 plus 12. That's equal to 15. I don't really care what the number is. All I want to know if it's positive or negative. So whether it's a 15, whether it's a 20, whether it's a 2, I don't really care what it is. I just wanted to know the sign. Okay? So 15 is positive. So what that means is anything over here is going to be positive. Any number I plug into the first derivative that's left of 0, less than 0, is going to be positive. You can pick another number if you don't trust me. Pick a -2, pick a -3, pick a -4. Any number that I plug into that's going to be, it's always going to be positive. Okay? Okay. So now I'm going to pick a number between 0 and 1, or 0 and 4. I'm going to choose 1. Okay, so I get 3 minus 12. Again, I don't really care what number I get for this for first derivative test. I don't really care what number I get. I just want it to be, I want to know if it's positive or negative. Negative. So that means in between, I'm going to get derivatives that are all negative. Bigger than 4. I'll plug in 5. 3, 5 squared minus 12 times 3. 3 times 25 is 75 minus 36. That's going to be a positive 39. Even if I'm wrong, I know it's going to be positive. Yeah, what is it going to be? Oh, times 5? Where did I miss a 5? Did I miss a 5 somewhere? Oh, I put a 3. Sorry. Thank you. That's important. So it'll be 60. 15. Okay. Positive. So I'm going to put pluses over here. So anywhere I have a plus means I got a positive derivative. And if it's a positive derivative, that means the function was increasing. So it was increasing before 0. When it got to 0, it was decreasing. And then at 4, it increased again. So from negative infinity to 0, it's increasing. From 0 to 4, it was decreasing. And then 4 to positive infinity, it was increasing again. Okay, that's one of the things I wanted me to do in the question, right? They said, where is it increasing and decreasing? So I'm going to need you to write intervals. Okay, so let me write some intervals here. Increasing, decreasing, okay. So using the first derivative test, we know where it was increasing, right? Where I had a positive um, derivative, positive slope. So that's from the left to 0, negative infinity to 0. So increasing was from negative infinity to 0. Is there anywhere else it was increasing? So we're going to write that one too. Now, you're going to write a symbol here that some of you may not have seen, or I think we've seen it before, but not for a while. The U, what does the U mean? Or. Or. The upside down U, the horseshoe, is and. We don't want to put and. And means it has to be both. Or means it could be one or the other. So it's increasing in this guy, or it's increasing in this guy. That's what we want to say, if it's multiple. Where is it decreasing? 0 to 4. 0 to 4. It's decreasing, right? 0 to 4, it's decreasing. The interval only goes from negative infinity to positive infinity. So from negative infinity to 0, it's increasing. And then it switches to decreasing. And then it switches to increasing forever and ever and ever. Done. Have we finished the problem? Because the problem asks for a lot of things. So go through it. Have we found every single thing that they wanted us to find? Yes, no, maybe. Is there something we're missing? Anybody? Yeah. The last part, right? The maximum minimums. We've done the work. We just haven't wrote anything about them, right? It asks for critical values. Boom. It asks for increasing, decreasing, right there. We just haven't found where the maximum or minimums are. So let's say max. Well, the easy thing is we've already done the hard work. We just got a label. So we know it's increasing before 0, decreasing after 0, and then at 4, it changes back to increasing. So that's why I kind of draw a picture. Is this what the function looks like? I have no idea. But it gives me a visual to see what the questions I'm going to ask. And right here, I have a maximum. Right here, I have a minimum. So at 0, I'm going to have a maximum. So I say relative max at x equals 0. And then over here, I have a minimum. Relative minimum at x equals 4. What if they want the point? Sometimes they want the point. Sometimes I only gave the x. Sometimes they want the actual point at which it switches from increasing to decreasing or decreasing to increasing. How do I find this point? What do I do? It's not very hard, but sometimes people get confused with it. So how would I find where that actual dot is on the graph? Uh-huh. There you go. Plug in 0 to the original equation, and that'll get you that value. It would be 0, comma, I think 15. 0, comma 15. And then 4, you would plug in 4 here, plug in 4, plug in 4. You would get 4, comma something. I'm not that good. I can't do that in my head, but you would get 4, comma something. That would be the minimum. Okay. Sometimes they'll ask for that. Sometimes that's okay. You just don't know. Okay. These are packed questions because there's a lot of stuff in them because you have to do this, you have to do that, you have to do this. So you just make sure that you answer everything. Okay. Sometimes they're packed questions. Sometimes they just want one thing. Sometimes they'll have a question and it'll just say, find the critical numbers, find all the relative extrema. Where is it increasing, decreasing? So I wanted to have a question that had all of them in there so that you can do all of them. Okay. So let's look at example number 2. Example number 2 is one of those. They don't ask for all that stuff. All they want is the relative minimum. All they want is the relative minimum. Okay. So I want you to do this one on your own. I'll give you about 5 minutes to do this one. Use the first one we did as a roadmap. We'll do it together, like I said, about 5 minutes. Okay. Okay. So the first thing you're going to do is find the derivative. You're still working. Keep working. The first thing you're going to do is find the derivative. So I got negative 3x squared plus 6x plus 45. Set that equal to 0. That's a quadratic, trinomial quadratic. Okay, you did it in Math 2 and in Math 3. And if you didn't know the direction, the steps are right on the board right there. Factoring trinomials right there. Okay, because that's what we're doing in Math 3. So you can do, most of you could probably do something like this, your multiplication x. So you multiply. So first thing you do is factor out a GCF. The GCF was negative 3. So you took out a negative 3. 1 times negative 15. And then you get a negative 2 here. So the two numbers that multiply to be negative 15 and add up to be, whoops, this should be a positive, are negative. So negative 15 and negative 2. So you get negative 5 and positive 3. Set them equal to 0, 5 and negative 3. Okay, those are the critical values. Okay. So I didn't do this part. I stopped here. So here, now I got to set up my first derivative test. First derivative test is negative 3. Plug in negative 3 to the derivative. So I get 9 plus 6 minus 15 on the inside, and then the GCF was negative 3. Again, I don't care what number I get. I just want to know if it's a positive or negative. I want to do everything mathematically correct, but in the end, I just want to know if it's a positive or negative. So on the inside, I get, what do I get, 0? Oh, yes. Why did I plug in negative 3? I plugged in -3 because if you plug in -3, if you plug in the actual number, you're going to get 0. So I shouldn't have plugged in -3. I need to plug in a number that's less than -3, less than -3. So let me plug in -4. So the same thing. So I get, on the inside, I get 16 plus 8 minus 15. So 16 plus 8 is 24 minus 15. That's going to be a positive number times a negative number. So my answer is going to be negative. It's going to be negative 27. But again, I'm just want to get to a point where I know where it's going to be positive or negative. Okay, so out here I put negative signs. Okay. Now, in between -3 and 5, in between -3 and 5, 0. Anytime you can use a 0, it's always beneficial to you to use a 0 because 0 cancels things out. So let me erase some of this other stuff here. 0, 0, 0. So it's -3. Everything cancels out. This cancels out. That cancels out. All I'm left with is -15. Negative times a negative makes a positive, so you're going to get positive 45, which is positive. Okay, let me go back up here, put some pluses. Last one is after 5. Any number after 5. So I'll plug in 6. Okay, so -3 times 36 minus 12 minus 15. So it'd be -3 times 24 minus 15, which is 9. So again, that's a -27, negative number. Okay, so let me go put up a negative over here. Okay. Okay, so now that I know this function here was decreasing before -3, and then at -3 it started increasing, and then at 5 it started decreasing again. Okay. Knowing that, we need to find the relative minimum. Now there might be more than one. In this case, there's only one, but there might be more than one. So don't just assume there's one. Well, in this case right here, there's a relative minimum when x equals -3. Relative minimum at x equals -3. That's why they say minima. Minima is the plural of minimum. So that's why there's no minimums. It's minima. So that's why they say that, because there might be more than one. Well, in this case, there was only one minimum at -3. Okay. All right. Okay, so we might not finish the next one, but at least want to get it started. So number 3, this one is one of the ones where you got to find all the things. But again, even though I just found the relative minimum last time, I still had to find the critical numbers. I still had to find where it was increasing and decreasing, right? So just because it asks for one thing doesn't mean it's an easier or a less problem, right? You still have to do all of those things. So we might finish, we might not finish, but I at least want to get you started on this. We'll pick it up tomorrow, but I at least want you to get, I'm not assigning anything new today. So try to finish this one if you can't. No big deal. We'll finish it tomorrow. So find the first derivative, make sure you match it. Because if you don't find the first derivative correctly, the rest of it's obviously going to be off. So I got x squared minus 4 on top, x squared plus 4, quantity squared on the bottom. Okay. Okay, now, so if I'm finding my critical values, what do I do? How do I find my critical values here? What am I going to do to find my critical values? So when you say set it to 0, you're not going to set the whole thing to 0. You're going to set the top to 0. If I set the top to 0, that takes care of 0, right? That takes care of when the derivative equals 0. And then I'm going to set the bottom equal to 0 separately, because that takes care of when the derivative is what? Undefined. Yeah, I'm not going to set the whole thing. I set them separately just because it's easier that way. Okay, so I'm going to set the top equal to 0. And then I'm going to set the bottom equal to 0. Now the left one, the one on the left, hopefully that looks familiar, rings a bell with some of you. What's true about the one on the left? I wish I left it on the board for my math 3 because that's what we're working on. There's a reason why these numbers are up here. I'm going to have 2 answers, definitely. Difference of squares. There we go. It's difference of squares. If you didn't know that, it's not that big a deal on this problem because you can just add 4 to both sides and then take the square root. But difference of squares probably would help because you're going to get 2 answers. Sometimes when people do this, oh, add 4 to both sides. X squared equals 4, x equals 2. Square root of 4 is 2. Yeah, you're right, but you also forgot an answer. Negative 2, right? That's why if you know difference of squares, you can do this. X plus 2, x minus 2 equals 0. And then set those equal to 0, and you get x is negative 2, x is positive 2. Okay. This guy over here. How do I solve that guy? Again, there's an easy way and there's a not harder way, but longer way. How do I solve that guy for 0? Tick tock, clock's moving. Anyone know? Anyone have any ideas? Yes.
Square root both.
Yes. Square root both sides. And then I would, is that difference of squares if I square root it? No, because it's not difference, right? Difference means subtraction. It's plus. There's no such thing as addition of squares. It's difference of squares, right? You can do all of that, but you want to know the easy way to do it? Is there a number you can plug in there that would equal 0? Pick any number. Is there a number you can plug in there that would be 0? Why not? Why no? Why is there no number I could plug in for x here that would ever be 0? First thing you're going to do is square it, and that's going to make it positive. And then you're adding 4, makes it bigger. And then you're squaring it again. It makes it even bigger. There's no way, even if you plug in -4, it's going to square it, right? So there's nothing here. The only thing, there is an answer, but it's imaginary. We don't care about imaginary in this class. Math 3, imaginary is fine, but in this class, we don't want imaginary. We just want the real stuff. So there is nothing here. There is no x value there. So it's not going to give us any number, any critical value here. Okay. All right. So that's where we'll stop. We'll pick it up tomorrow. All right.